Hi, I follow along with Paul McWhorter's Fusion 360 and 3D printing lessons. And uh, lesson 9, he just showed how he would do the homework that he showed us or that he assigned in lesson 8. So I'd already finished that. So he didn't really leave any homework this week. So I wasn't going to do a video, but I decided that I had a project come up in the last couple of days that I designed in 3D print, and figure I'd give you a real world example of how you can put 3D printers to use. So on the farm, I have a sprayer, and a 15-gallon sprayer that we spray weed killer with. And this is the original pump for it. And it finally gave up. So I went on Amazon and found this one. It's a little bit bigger, better, and stronger. And who doesn't like that? So I decided to order this one. As you can notice that the footprint is different, mounting footprint is different. So had to make an adapter block for it. So also this pump originally was facing this way. So I had to take that into account when I took my dimensions, make sure I kept them straight in my head and everything. So um, I ended up with this print in PETG. PLA doesn't last out in the sun, so made out of PETG. It seems to hold up better. I got some parts in my greenhouse that are holding up okay, so made it out of this. Like you say, the surface finish. This is some old. My bed was a little dirty when I did this, and got a little purple parts in there too. But you can see this is the original footprint, and this actually, the tank has uh, fastenings in it, so you could screw right into the tank. I don't know what kind, some kind of T-nuts or something inside of it. So they already had that. And then this is going to be for my new part. I know this, I must have my camera on an angle because this and this and this are actually parallel. So I should have held my camera flatter. But yeah, it's looks like a horseshoe or something here. But anyhow, um, I had some flathead screws with some tapered heads on them to fit in these holes for going into the original parts. And then this is going to be for where we mount the new part. And the back side of these 4 holes, I actually do what's called a captive nut, where you make a hexagon same size as the flats on your nut, and uh, press them in when you're done. That way you have a way to fasten when you get done. Like I say, I usually make them about the same thickness down as uh, the part that we have. So anyhow, that's what we got. And you can see that this is the thing, and this is the new pump mounted. Like I said, the original pump was mounted this way, but this one I decided to do it. As you can see, this is kind of close to this section here, so I also had to shift the whole thing over a little bit. So let's see if I can share my camera. I'll stop share. And this is a little drawing that I did of the pump. You can see that this is the inlet and outlet when the pump was in this orientation. This is the old pump and this is the new pump. So the old pump, when it was in this orientation, you had 2-inch 250 this way and 3-inch 100 thousandths this way. Sorry about the metric people, but I do almost everything measuring in inches. So, and then the new pump, it had 3 inches this way and 5 inches that way. And like I say, it was turned. And I just mentioned that we had to shift this over. So here's the old footprint. And this is going to be where the new footprint is. And with it shifted over, I decided I need to shift it over 1 inch 200 thousandths. So that's where that's going to be. So I decided I just drew these rectangles, and I was wondering how am I going to go ahead and dimension all these things? I said, well, we've got the corners of those rectangles. That'd probably be the way to do it, is get these rectangles. So let's get to the thing and see how we go. Go back to share. Go back to sharing, and probably need to turn off the camera. All right. So we might as well go to the Fusion 360. So of course, I've already created this, but I figured I'd show you how I decided to create it again, just to give you an idea of my thought processes. So we're going to sketch, and we're going to sketch on the XY plane. And my go-to seems to be the center point rectangle and start at the origin. So you can see that we got, this was going to be 3.100. We're going to tab over, and this is going to be 2.25. That was our one rectangle. Then we're going to draw another rectangle, and this is going to be for the bigger ones. I'm going to just dimension this. So we're going to dimension this as 3 inches this way and 5 inches this way. All right. Then, like I said, we wanted this set of lines to be 1 inch 200 apart. So we'll go ahead and dimension that. 1.2. All right, so we got that done. Only thing we have blue left is the top and bottom, because we haven't set that. We could work with a midpoint, but these dimensions are set, so I'm not going to worry about it. So we know this is 5, so we're just going to dimension from here to here and call that 2.5. And there we go, everything's black. So we're going to escape out of this and make sure we're on window select. We're going to select it all, and we're going to say, make it, since we don't want these to be part of our drawing, we want them to be construction lines. So now we got construction lines with all these points that we can use to make our holes. So now we can start with that. So now we can start making our holes. So I needed on the smaller ones, they had to meet up with the tank plastic, and they are pretty hard coated in there, and hard mounted, so didn't have a whole lot of play in those. And I was just measuring it with the calipers, just eyeballing it, opening the calipers till you thought you were at the center of the hole. So I decided we're using number 8 hardware for this, and that's like about 160 thousandths or 170 thousandths, I think, or something like that, diameter screws. But I wanted a little bit of play here, so I'm going to make these holes on the small part 250 thousandths. So I'm going to go ahead and make a bunch of, these are the outside ones. I'm going to go ahead and make them all since I started that. And like I say, I'm not dimensioning them as I go. I'm going to just make them, set them all, and then dimension them all at once. Escape out of that, and then D for dimension. 0.25. 0.25. 0.25. All right, so they're all done. And these holes, I just decided to make them 200 thousandths. Like I said, I just give it just a little bit of clearance. And the mounting on the pump is rubber mounting, so there you can move them around. It's rubber mountings for shock absorbing, and so that makes it easy for us to do this. So 0.2. All right, so we got all of our holes done, and now, but we don't have any solid object to make, so I'm just going to make a rectangle around everything, and then just dimension it, give us clearance so we can do it. So it just doesn't matter what size we make this. So we're going to just make the rectangle, and then, like I said, we're going to dimension it. So I'm going to, from the farthest center line of any of the circles, we're going to make it a 1/2 inch. I guess that'd be about 12 millimeters of metric people. So we're going to go from here to here, say 0.5. And the same way from here to here, 0.5. From here to here, 2.5. And from here to 0.5. All right. Oops, that was the wrong line. So I'm going to delete this. I'm still in there, so I got to get out of it. And delete. Okay, so that's not the one I want. So I can still pull this one, so I won't pull it down because it wants to be 0.5 from the bottom. So back to dimension. Hey, there we go. So that's better. So we're out of dimensions now. So we could go with that and just extrude it and take out the holes, and we could use it like that. But a couple things, you don't really want to waste a lot of plastic that you don't need to, as long as you got the strength that you need for it. And also a big flat item like this, it's going to be about what, 6 by 4 or 5, 6 by 5 or something like that. You got a good chance if you got a solid piece on your bed like that, that if your material has any chance of warping, it's going to probably warp. I try to put holes or get parts out of it the best I can. So the first thing I see I want to do is, we got all this area up here. I could chamfer them off with a thing, but I like radiuses, so we're going to go ahead and tell it that we want a radius. And this, we're going to actually make it a nice big radius when we're done, but 1.5. Let's try 2. See, 2 actually looks all right, so we'll use 2. All right. Saving, printing all that, and less corners to come up on us as well. But another thing we can do is we can cut out a lot of this center that really isn't helping our strength of our thing. You could go in and draw a couple circles. I usually try to use curved surfaces. If you cut a rectangle out, that actually might make it a little bit weak in certain cases or whatever, but the circle has a lot of strength to it. So we're going to do curved surfaces, but instead of a circle, I'm going to go up and do a slot. We'll do, and I decided to do a center point slot because we can start right here in our center point. And we can go up and we want to be there, and then we want to open it up. And this is where you put a dimension. I think I want 2. I don't want 0.2. I want 2 on here. So that'll be good. See, we're far enough away from all of our holes that we should be fine. So we'll hit enter that, and it's fully defined. So we're good there. So we also have, there's a bunch of stuff over here that we could etch out too. So I decided you could do whatever you wanted here, but I also decided just to create another slot. I'm pretty much doing the same thing. I'm gonna make this horizontal vertical when I get a chance, but actually gonna make it exactly the same size. I probably could have copied and pasted, but you can see we're not quite fully defined here. Probably need to do a horizontal vertical maybe with this hole here. There we go. There we go. Now we're fully defined. So let me see. On my first one, this is where I stopped, and I think I'm going to stop here again because I'm going to show. Paul always likes to do is radiuses here, but if you decide a little later that you want to do the radiuses, and you can always do them in the 3D part. So let's go ahead and stop on this. So we're going to go ahead and finish this sketch. Let's go ahead and put it in home position. And we actually only have to click on one part. So we're going to extrude, and we're going to say we're going to extrude all of that. So we're not extruding any of the holes, and we're cutting out all these parts here. So I went up 0.350, 0.35. All right. So that's what I got so far. So if you noticed on the part that, like I said, these here were tapered so that they could take the flat-headed bolts that I have. So we can go ahead in here and modify and put a chamfer on them, and we can select all of these 4. This is the 4 smallest ones. And I can't remember what chamfer I put on them. What I put a 0.15. Yeah, that's probably what I did, 0.15. And that'll take the flathead bolts into the hard plastic. And like I said, they're a little bit bigger holes than the other ones, so that should be able to have enough play to get it. Since you saw the finished part, you could see that we did have that. Now, I talked about the captive nuts. So they're actually, because this is going to fasten to the tank, and then the pump is going to fasten down to these. So we're going to have nuts on the back side. So we actually have to sketch on this back side here. So we're going to say sketch, and we're going to sketch on that flat part. Okay. And we're going to have to create hexes, polygons, and the circumscribed is the ones that you're measuring across the flats on a thing. So that's the very first one, is what you want. And kind of click in the center. And I forget what I put on these. 173. So I'm going to put 0.173. And if you don't hold these exactly right, sometimes you might have to go in and straighten them back up with a horizontal vertical. Not that it really matters. The nut's going to go in no matter what the orientation is, but you got to kind of think about what you're doing. All right, and you got 4 of them. Like you say, you can see they're blue. You could go in and make them horizontal vertical, but yeah, we'll do that. You can say horizontal vertical, horizontal vertical. Horizontal vertical. And now we're all good. And we'll finish our sketch and go home. Up home to flip it over. So I have to flip it over because we got to extrude those down. And let's see. So E for extrude. And now you want to sneak in here and you want to pick that part. And you want to pick this part. You see our arrow is facing up, so we know we're going to have to go a negative number. And so I'm pretty sure I went 150 on this, so it's a negative 0.15. There you go. We got nice little areas that's going to capture our nuts. So our tapers on the other side, they're at 45 degrees, so they're going to print just fine. But you actually, if you print it with this on the bottom, it's the way we designed it, but that's okay. You're better off when before you slice it, is to flip this over so that these hexes are on top. That way you don't end up with those overhangs. Most printers can handle this small overhang now, but they're nice and clean if you do them on the top. And like I said, there's no reason with the 45 degrees on the bottom that they're not, the 45 degrees are going to be just fine. So I got this far and I was getting ready to print. I said, I just don't like those things here. So I just decided I'm going to do a fillet on them. And you can say when they're 3D, you can do this and you can just go in and pick all the corners you want. And we got them. And I think I put these as 0.5. Let's see. Yeah, that looks about right. And that's what we got. So, and like I said, in a couple hours time, and I think it took about 3 hours to print this on my printer. And within a day, I had a custom made base that was ready to be adapted for what we were doing. And like I said, using the PETG, you can use it outside without too much. We'll see how long they last, but so far I've had stuff in the greenhouse for 2 years and still not falling apart. I've put a something PLA in my car in the heat in the car, and of course it gets up to 120 degrees in the car, and you go in, whatever it was almost at the melting, not the melting point, but where deformed on its own and everything. So PETG has I think about, I don't know, 30 or 40 degree difference in temperature that it'll stand up to. So hopefully this won't ever get that hot around here. So anyhow, that's what I got for this week, and just a little bit of stuff that you can do to make your life simpler. Thanks for watching, and look forward to more videos from Paul.